Now we're going to see another property that water has, and it's that affects our lives, and these are tides. So let's see what causes tides. This is the Earth, and if there were no sun or moon, the water level would be the same throughout the entire globe all the time. But because the moon, this is the moon here, because the moon is orbiting the Earth, the moon exerts a gravitational force that pulls onto everything, you and me, but because the water is more fluid, it's gonna change more easily. So what you find is that as the moon orbits the Earth, the water level, it's not even, it actually puckers towards them when the gravity pulls the water towards it, and it gives it this shape here. And as the moon orbits the Earth, the moon isn't stationary, the moon moves around. So as the moon orbits the Earth, so let's say now the moon is over here, what you're going to find is that the water peak is going to follow the moon around. So now it'll be pointing in this direction. So what that means that for you, as let's say that you're standing in the same location, what you're going to see is when the moon is above head, so here the water level is going to be this much, but then the moon goes away, and now the water level, let me try to make a better picture here. Let's just say that the moon points in this direction. So as the moon moves around, but you're staying at the same location on the beach, you find that one time of the day the water level is really high, or one time of the month, and then you again standing at the same location, now the water level goes really low. So this change in water level, these are called tides, and they have to do with the moon. But it is not just the moon, though. Not only the moon exerts a gravitational force on you and me, but the sun does as well. And it's the combined effect of the sun's gravity and the moon's gravity that actually generates the tides. And we'll look at that next. So this picture shows you how the sun and the moon interact to give us high tides and low tides. So first, let's look at this one here, which are going to be high tides. So here, the sun is out of the picture, but the sun is over here. So I'll redraw that here. This is the Earth, and this is the sun. And the moon orbits the Earth, so there's going to be a point in time when the moon is going to be between the Earth and the sun. It can be actually, between, let's just say, lined up. So sometimes the moon is going to be on this side here. Well, let's just look at this case first. So in this case, you have the water. This will be its normal height, but because of the moon, the height would increase by this much. And now because of the sun also exerting a gravitational force, the moon, the water level increases by that much there. So these are going to be when you're going to get the highest tides, and these are called spring tides. So spring tides are when the sun, the Earth, and the moon line up. And that occurs, let's say that you're standing here. This will be during noontime, but it also occurs when the moon is behind the Earth here, which will be at the midnight. But in either case, though, what matters is that the Earth, moon, and sun are lined up. So that's going to be when you're going to get the biggest tides. So what's special about, so the spring tides, the biggest tides are called spring tides, and they have the largest tidal ranges. So what that means is that if this is the normal water level, during spring tides, the water level is going to go very high, but it's going to go very low, the biggest, highest that it can, and the lowest that it can. So these spring tides, they occur, as I drew a little while ago. The spring tides occur when the moon is during full moons. So this is going to be, so let's just say again that you're standing here. So this is going to be, the center of the earth. So when the moon is behind you, that's going to be, you're going to see the moon at night. So that's going to be a full moon. And when the moon is overhead, that's going to be during noontime at a new moon. So spring tides occur when the earth, moon, and sun line up, and that occurs during full and new moons. So the earth, sun, and moon line up during full and new moons. So that's one kind of tide, and you can again see it here. As the moon orbits the earth, notice that the bulge of the water always follows the moon. So that's one kind of tide, but now we're going to look at another case. So again, we're going to assume that the sun is here, and this is the earth, and the moon is going around the earth. But now there's going to be, the moon is going to take all different positions, but there's going to be another special position where, so this is the earth, and then this is the sun, and this is the line between the earth and the sun. But there's going to be another time when the moon, as it orbits, it actually winds up here. So that here, the distance, the line between the earth and the sun, and between the earth and the moon, are at 90 degrees. And so what happens here is, let me just get rid of some of this stuff here. The sun's gravity is pulling the ocean in this direction, and the moon's gravity is pulling it in this direction, and effectively they cancel out. And because of that, during when the earth, moon, and sun line up at night, they don't line up, they're at 90 degrees. So if this was the normal water level if there were no tides or no sun and moon, what you find is that the water level drops. Well, actually, you're going to get the least amount of change in water level. It'll change, but barely at all. So let me just get rid of this here. What I meant to say is that if this is the normal water level during these tides, the water level is going to just move a little bit above or a little bit below, barely any change. So here, these are called neap tides. So neap tides, this is when you have it's going to be the opposite of the spring tides. They're going to have the least tidal range. And neap tides occur when the sun, moon, and earth are at 90 degrees. And these occur when you have a half moon. So you can see it here, like this. Yeah, you can see it here. So let's say that you're standing here, you're seeing both the shadow side of the moon, both the shadow side and the lit side. So these types, the neap tides, occur during half moons, or what are called quarter moons. So they occur during quarter moons. So for perspective, let's look at this idea again here. So this is the sun. If you're standing here at noontime, the sun is directly overhead, and the moon is also directly overhead, but you're seeing a shadow side, so you see no moon. So these are new moons. And now let's say that now this is at midnight. So now let's say that you're standing here, And now at midnight, the moon is again overhead, but now the sun is behind you. So now what you're seeing is the lit side of the moon, and so that's going to be a full moon. And so whenever the earth, the moon, and the sun line up, you're going to get the biggest tides, which are going to be the spring tides. And whenever they line up at 90 degrees, you're going to get the least amount of tidal range, or the neap tides. So again, you can see here, so this is what causes tides. It's the gravity between the interaction between the gravitational force of the moon and the sun. When the sun, moon, and earth line up, you're going to get the biggest tides. And the moon keeps on rotating, and the bulge the water bulge changes directions. And there's going to be a point where, actually that is the picture here, where the distance between the earth and the moon point in this direction, and the distance between the earth and the distance between the earth and the sun point in this direction, and the distance between the earth and the moon point in opposites, or at 90 degrees, and there they cancel, and you get the smallest tides. Okay, so we completed the lecture for chapter 15.